We don't want it to freeze airburst our pipe, so we're going to end up with an antifreeze solution in it. We do end up now with a more stable design temperature, loop temperature. And we'll see a graph where you get to see how loops are affected by ground temperatures. So first was that open loop, right? Open loop, the advantage, lower installation cost than the closed loop. Okay? Pumping cost. So the pump is smaller. That first cost of the pump is smaller. That operating cost on the pump is smaller, uses less electricity. Okay? Disadvantage, typically a smaller system, because typically we're dealing with a limited water supply. If I have a well and it produces 5 gallons a minute, and I'm pumping it out of that well, right? And then we're dumping it out into the pond, similar to the picture up there. I have now a 5 gallon a minute threshold. I can only design to that size. Okay. Climate conditions can limit the usage. If it's pumping from open water, maybe it's not necessarily deep enough water in terms of it will freeze up and we will lose our capacity at some point. Environmental issues, okay? How does the Cataraqui Regional Conservation Authority feel about you pumping water in and putting it through your heating and cooling system and dumping it out into a pond or into a creek, right? How does the Ministry of Fisheries find? What do they think about that? Because you are changing the temperature of the water differently than Mother Nature, right? So that fish spawning bed might be affected. So those become environmental issues that you need to check on as that homeowner, as that potential systems being put in. And again, like I say, fouling becomes a bigger factor. And by fouling, what that means is now we're taking that dirt and it's getting into our system because it's open. And we're now get fouling on that heat exchanger. So that heat exchanger gets dirty. And that means we lower our system efficiency because we have a dirty heat exchange surface. Okay. Closed loop is traditionally the result of that. We end up moving away from open loop designs and going to closed loop. The majority of ground source heat pump systems are going to be closed loop systems. First one, of course, is vertical. We can talk about a vertical system. Requires less land than the next couple, which are horizontal type systems, okay? I still got the spelling error because least amount of total piping, right? The loop length is shorter on a vertical loop than on a horizontal loop, okay? Can require less pumping because, yeah, we got less pipe length, less pumping energy required. The pipe length is shorter because I'm going down further. I'm getting more stable earth temperature the further down I go, okay? Issues, though, drilling costs are high, typically. And again, as I stated on Tuesday, that's a factor. Are we drilling into sand? Are we drilling into rock? Are we drilling into clay? Those are those variables that are going to be site-specific to your home. Backfilling requires special material and skill, right? We have to backfill with the appropriate materials because we might need to dig it up later. Hopefully not, right? And we obviously don't want to damage the pieces of pipe we just laid in the ground. And you have that potential for heat buildup if we put a lot of systems in a congested urban environment, and I'm now dumping air conditioning and dumping heat from the home into the ground. If we have enough systems in place, how the ability of the earth to dissipate that heat will be diminished, right? And once I have heat build up, then my system's working harder to do its air conditioning function. So we might lose some capacity at that point. That's just a potential issue, though. Here's a horizontal loop picture. Okay, so now we're trenching as opposed to boring holes into the ground. We're going to trench. We're going to put in our system, of course, now, if we're not drilling into the ground, we got a lower cost. Heat buildup is not as sensitive as a vertical loop because now we're not concentrated in a small land area. We're in a large land area. Okay? You're going to see a picture and you might be surprised what type of land area we're talking here. Disadvantages is that requires more land. So if we're in that urban environment and on that small 80-foot by 150-foot lot, you probably have to put in, you're going to be putting in a vertical loop. But if we have an acre, 2 acres, 3 acres, then we're looking at utilizing horizontal because it is a cheaper installation. Okay? But as I stated, you're going to have greater temperature variation in the ground. And you'll see that in the graph that's coming up. Okay? More piping's required because we do have that temperature variation. When I go vertically, I'm a stable temperature. Now you hit that magic 55-degree earth temperature, 55 degrees Celsius, Fahrenheit, temperature. And it stays constant. It's the same temperature if we're at 100 feet or 200 feet down.
How deep do you have to dig?
It's really dependent, Ben, on what ability you have. I mean, typical boreholes are 200, 300 feet deep, right? Because we're going to need 200, 300 feet per ton of air conditioning equipment, okay? So on a typical house, we have like 3-ton, or bigger houses nowadays, it's 4-ton and 5-ton systems, right? So we need 5, you'll see it in the later slide, but you'll see that you need 5 or 6 boreholes at 200 feet deep, okay? And you'll see in the slide as well how much trenching you need. So you have more pipe, right? More pipe, big hole. We got more potential for damage when we backfill. You're still needing that for your heating requirement. You're doing the heating, right? The air conditioning needs a little more bigger space than, say, the heating, but I mean, they're both typically the same, right? So.
I heard that with this geothermal system, the ductwork in the basement, an existing ductwork from an oil furnace is not sufficient.
That's what I mentioned earlier, yeah. Well, that's what I mentioned earlier, right? You're dealing with a cooler supply temperature, right? Being we're dealing with a cooler supply temperature, we actually need to supply more of that air. So that ductwork, if you're doing a retrofit, that ductwork might have, you might need to be changed. It depends on your house, right? I mean, you buy, George is here, you buy your ductwork, and you buy 4-inch, 5-inch, 6-inch round ductwork, right? So it's dependent on when they built the house, you know, did they try to cost save and downsize that ductwork? And now it's going to be too restrictive when I put that heat pump on because I want to move more air through there. Now I can move more air through there. I can put the fan, the blower on there that'll push it through there. But if we move it faster, then we're going to have noise, okay?
It's more noisy anyway.
Yeah, well, I mean, more air that goes through that piece of pipe, the more air noise you're going to have because we're moving at a faster speed through the pipe. So that potential for that whistle is going to increase, right? It's already, like you say, it's already noisy to an extent, but I can move, if I keep moving up and pushing more and more air, I'm going to get into where you actually hear like almost a whistling when it comes on.
The building, there's a building being built here in Kingston in the future
Mm-hmm.
that will use thermal energy. Would you think it's horizontal or will it be vertical? I'm just wondering.
That's really near the lake. It might be a closed loop in the lake. I mean, it's very site